So we'll take a look at section 2.6, exercise 42. This is linear versus angular speed. Linear versus angular speed. And so they start with a wheel of radius 30 centimeters. So that's 30 centimeters. Revolves at a rate of 10 revolutions per second. Yeah, so it's going around either clockwise or counterclockwise at 10 revolutions per second. And a dot is painted on a point P. And they show a picture up there. Oh, they actually show it going clockwise, but fine. So there's our point P somewhere out there at less than the radius. And it says, hey, find, and they measure theta from here? Gosh, I don't like that at all, but we could always change the picture if we wish. But they want us to find if x is the distance here. You see what's happening is that from that point it'll go, sort of this back and forth like this on the x-axis as far as that. If you think of a shadow maybe from a light above it. So it'll be going back and forth, and so we can find this as a function of theta. And so let's see, a wheel of radius 30. Oh, I see. Okay, I didn't look at the picture very carefully. They say that that point is at 30 centimeters. Okay, so that is 30 centimeters. Okie doke. Well, so in that case, what I know is if I use the cosine function, right, I know cosine of theta is x over 30. And now, theta, they've got, to me, they have this picture all messed up. And so to get their answer, we do need to be well, actually, I'm not sure we do need to be careful because they have the exact opposite of everything we would normally do. So normally, right, we would draw things this way. We would come out here to x, and there's our 30, and there's theta, and we would say cosine of theta is x over 30. Well, actually, they drew everything exactly backwards. And so I guess this picture will work for that relationship as well. So we'll go with that. Okay, so we have our relationship, and now we can take derivatives. Derivative cosine of theta with respect to t is equal to the derivative of x over 30 with respect to t. And so we get derivative cosine is minus sine theta, and then d theta dt is equal to 1 over 30. And then the derivative of x, so dx dt. Okay, so that's pretty simple to get that relationship. What do they want? Dx dt is a function of theta. That's nice. So dx dt is a function of d theta dt in theta is equal to minus 30 sine of theta d theta dt. But they told us d theta dt was 10 revolutions per second, and so we get minus 300 sine theta. And so what that says, let's kind of look at that, right? When theta is 0, it says we're coming in at 0, you know, it's not changing at all. And then it's negative as theta increases, and sure, right, if I redraw the well, even going with this original picture, right, as theta increases, the point X that's underneath P is shrinking until we get to right there, you know, right over top of the origin, and then it's getting bigger again, but in the negative direction, so it's still shrinking until we get over to theta equal pi, in which case sine is 0 again, and so it would stop and then come back the other way. So that looks good, minus 300 sine theta. So there we go. That is, what, part A. So that was A. And then B, use a graphing utility to graph the function. Okay, and so we can do that. B will graph. That's a pretty simple thing to graph. Now, we'll want to use X when we do that. So we go here and get rid of that and get rid of that. And so we'll just say f of x is equal to negative 300. Functions here, sine of x. Close that off. Okay, so there we go. That doesn't, trying to make it smaller, that doesn't look really good, does it? So what I'm going to do is y-axis, I am, let's see, can I, awesome. Okay, so now I need to get that one. I'll go minus 300. Minus 300. Awesome. Okay. And maybe the x-axis, well, that looks fine. So, good enough. I can't seem to... maybe I've got the pen too close or something. Nope. Yeah, I can't do it with my fingers making it any bigger or smaller, but what we see is, right, you know, here's our function, and this is the derivative. When is the derivative biggest in absolute value? You know, here and here. And where are those spots? Those are like, you know, 7 pi over 2. What's that one? 3 pi over 2. And this is pi over 2. Right? So pi over 2, 3 pi over 2, and so forth is when it's biggest. That's when it's directly over the center. And then when it's the smallest, when it's out at the edges, multiples of pi. And so that's what it's asking in C. And it says find dx dt when theta is 30 degrees and 60 degrees. Well, 30 degrees is pi over 6. So I can go in here and just say, well, what's f of pi divided by 6, and that's minus 150. I can finish that off that way. And then, what was it, 30 degrees and 60 degrees, and so I can do the same sort of thing, f of pi over 3, so pi divided by 3, and go out there, and that is minus 259.8. Okay, well, there we go. Those are our values for our derivative, and that's 42 A, B, C, and D.